Okay, these are homework problems for exercise 12.6, roots and coefficients of polynomials. It's extension 1. Okay, question 20 in exercise 12.6. Solve 6, does it say solve? Oh yeah, solve 6x to the power of 4 plus 5x cubed minus 24x squared minus 15x plus 18 equals 0 if the sum of two of its roots is 0. So you're going to let your roots be what? If the sum of two roots is 0, then they must be opposites of each other. So let the roots be alpha minus alpha. Be alpha and minus alpha, because if you add those two together, alpha plus minus alpha is 0. Just like 2 plus negative 2 is 0, they'd have to be opposites of each other, like same magnitude, opposite sign. So your roots are alpha and minus alpha because that's the sum of those two. If I do alpha plus minus alpha, I get 0. So the sum of two of the roots is 0. How do we know that we've got 4 roots here, girls? Yeah, it's the polynomial is to the power of 4, so we've got 4 roots, okay? So our roots are alpha, minus alpha, beta, and gamma. So what are we going to do next? Sum of roots, let's go one at a time. Alpha plus minus alpha plus beta plus gamma. You know how we've got A is what? B is C, D, E. Yep, A is 6, B is 5, C is negative 24, D is negative 15, E is 18. And remember, we go minus B on A, C on A, minus D on A, E on A. Do you remember that? We always start with minus B on A. So sum of roots one at a time is minus B on A. So if you do alpha plus minus alpha, you get beta times gamma. Now, what's negative B on A? It's negative 5 on 6. Negative 5 on 6. Okay? What else could we do?
Isn't that beta plus gamma, not beta plus?
Oh, sorry. Yep, it is beta plus gamma. Thank you very much. Okay. Start with sum of roots one at a time. Okay? One at a time. Let's do the product of roots, which is really sum of roots 4 at a time. Do you know what I mean? Which one's that? You go minus B on A, C on A, minus D on A, E on A is the last one. So its product of roots would be alpha times negative alpha times beta times gamma is B, C, D, E. Positive E on A. Now, what do we get? Negative alpha squared times beta gamma is 18 on 6, which is 3. I'm going to take that negative to the other side. So alpha squared beta gamma is negative 3, because negative alpha squared beta gamma is positive 3. So alpha squared beta gamma is negative 3. We still can't solve this because we've got 2 unknowns up here, but we've got 3 unknowns there. We can try 2 at a time or 3 at a time. And let's try 3 at a time. Sum of roots. You know why I'm trying 3 at a time? Because you get less of them. You only get, if you do 3 at a time, you're only missing out 1 root in every combination. So let's do our first group of 3, and what have we got? Negative alpha squared beta. Like I did those 3 first. I missed the last one. And then I'll miss the second last one. What would the next one be? Negative alpha squared gamma. So I've missed the last one. I've missed the second last one. I'm going to miss the second one. And then I'm going to miss the first one. Negative alpha beta gamma. Oh, that's good. Because alpha beta gamma and negative alpha beta gamma cancel. This is looking good. Girls, I've got the first three times by each other, and then I'm missing the beta. So the second one's negative as well. Okay with that? Remember, sum of roots 3 at a time. I'm doing 1, 2, 3, missing gamma. Then 1, 2, 3, missing the beta. Then I'm missing the negative alpha, and then I'm missing the first one, missing the positive alpha. Now, don't the last two, what does that equal? It's minus B on A, C on A, minus D on A. This one's minus D on A. Because it goes like this. Minus B on A is 1 at a time. C on A is 2 at a time. Minus D on A is 3 at a time. E on A is 4 at a time. Remember that?
So it's 15 on 6.
Well, girls, what's good about this is that the last two cancel. You know why I didn't choose 2 at a time? Because you get 6 of them. Too many. I don't want to deal with that mess. And I'm hoping that 3 at a time would be a little bit more suitable. You would only go to that one with the 6 different ones if you really had to. So, girls, can you see the last two cancel? So what have we got? Negative alpha squared beta minus alpha squared gamma is negative D on A. Look at all these negatives. Why don't I just take everything to swap sides of everything, and won't I lose all the negatives?
But
So,
either way, the 15 on 6 is anyway because it's negative 15 on 6. So it's negative.
I just want to get these negatives out of here at the moment. Oh, all right, let's just put what it is. What's negative D on A?
15 on 6.
Yep, all right, so that's 15 on 6. What did I factorise out here? I'll take a negative out. What else can I take out? Alpha squared, beta plus gamma. Oh, this is looking good.
So we can put beta plus gamma.
That's it, right, from part 1. So now we're going to substitute beta plus gamma is negative 5, 6. This is good. Can you see where it's from? Girls, are we okay here? We took a negative alpha squared out as a factorization, left with beta plus gamma, not minus, because you got negative times positive. Negative times positive is negative. Okay, so we get negative alpha squared times negative 5 on 6 is 15 on 6.
So we can times.
Well, negative times negative is positive. So I got 5 alpha squared on 6 is 15 on 6. You don't, well, look, if the denominators are both 6, doesn't it mean the numerators have to be equal?
Yeah.
So 5 out, yeah, that's the same as multiplying both sides by 6. But look, if the bottoms are the same, if the denominators are the same, the numerators have to be the same. If the two expressions are equal. Now what do I do?
Then you move the 5 on.
Yep, so alpha squared is 3
And alpha equals
plus or minus root 3. And aren't they opposites of each other? Good. So we're nearly done.
And now we sub in.
So now we sub that into equation 2.
Yeah.
So can I just come back here now? So we're going to sub alpha is plus or minus root 3 into equation 2. Now, girls, can you see what equation 2 is? It doesn't matter if I substitute positive root 3 or negative root 3. It's being squared. So what do I get? I get root 3 plus or minus root 3 squared times beta gamma is negative 3. Well, no, because when you square the negative, you'd get a positive. So it's just 3 beta gamma is negative 3. So beta gamma is negative 1. So whether I do root 3 squared, I get 3, and if I do negative root 3 and square negative root 3, it's negative root 3 times negative root 3, I get 3. So I'm going to call this one equation 3. So going back, I'm going to rewrite equation 1 again. So equation 1, I'm just rewriting it again, and it's this. Now I can solve because I've got 2 unknowns, beta and gamma, and 2 simultaneous equations. So what do I do?
Beta equals negative 1 on gamma.
Yeah, beta is, you can do negative 1 on gamma, and you can put that in there. So sub in 1. Negative 1 on gamma plus gamma is negative 5, 6. What are you going to do now? What don't you like about that equation? All right, what I did, I had equation 3, and then I looked back up the page where I had equation 1. I've rewritten it. I've got 2 unknowns and 2 equations. That's simultaneous equations. What I've done is rearranging equation 3. So I rearrange equation 3 to give me beta is -1 on gamma. Or I could have just rewritten equation 1. Either way, it doesn't matter whether. What don't you... Yeah, you want to get rid of 2 things there. The y and the 6. So girls, to get rid of the 6, you'd be multiplying through by 6, and to get rid of the gamma, you'd be multiplying through by gamma. So you multiply through by 6 gamma. Do you get that? You try to get rid of the divide by 6, and you try to get rid of the divide by gamma. So you'll be timesing by 6 and timesing by gamma. Do it in one step. Times by 6 gamma. So you're multiplying multiplying through by 6 gamma. Times this by 6 gamma, you end up with 6 gamma on top, on the numerator. What do you get? -6. No, not gamma. You get negative, all right, you get negative, oh no, you get -6 gamma over gamma plus 6 gamma squared. I'm multiplying by 6 gamma.
I thought the 6s and the gammas cancel. That's the whole point of it.
Wait, not all of them. Look, if I'm timesing this by 6 gamma, I get -6 gamma on gamma. If I times this by 6 gamma, I get 6 gamma squared. If I times this by 6 gamma, I've just shown the step because people are making mistakes when they do this. That's why I'm showing the steps. So what cancels here? The gamma. I get -6 plus 6 gamma squared equals, what cancels? The 6's cancel. And I get -5 gamma. Now, I want to take everything over to which side? So, to the left where the squared term is positive. Plus 5 gamma minus 6 equals 0. I have to go to the next page. Ready? You can solve. Girls, can you factorize that? So you can try crisscross, or you can try 3 gamma, 2 gamma. All right, let's see. All right, let's.
-1 plus 6.
Or you can try the quadratic formula. Look, a quick crisscross, you could go 6 gamma, gamma, or we could go 3 gamma, 2 gamma. Now, factors of 6, if you put 6 and 1 there, that's not going to work. If you put 6 and 1 there, that's not going to work. If you put 3 and 2, that's not going to work. 2 and 3, that's not going to work. Forget that combination. It'd go for the 3, 2. I've just tried all these. Like, I tried that with the factors of 6. It doesn't matter whether they're positive or negative. You can't get any combination. All right, this. I reckon 3 and 2. 9 and 4 can give me 5. So, you need more pluses than minuses. So, plus here gives you plus 9y. Minus there gives you minus 4y. Okay? So, we had 6 gamma squared plus 5 gamma minus 6 is 0. We've got 3 gamma minus 2, 2 gamma plus 3. Just check. 6 minus plus 9 minus 4y. Yep. Always check your factorization once you've done it, please, girls. Always. So we get gamma is 2/3 or gamma is -3 on 2. Nearly done. And then you can just sub those both into, I put them into equation 1. And I'm rearranging equation 1. I've just rearranged equation 1. Equation 1 is beta plus gamma is -5, 6. So I've just rearranged it to gamma is -5 on 6 minus beta. And sub them both in because you need, actually, ooh. Why am I getting, all right, we'll just substitute them both in, just see what we get. So we get gamma is -5 on 6 minus 2/3 which is,
Miss, do we have to substitute?
yeah, how else do you get?
But why is that you substitute?
I have a feeling you're going to get the other answer.
Why you substitute gamma result?
Girls, I have a feeling that when you substitute this one, you're going to get the other one. And when you substitute that one, you're going to get that one. Because you're only meant to have 4 roots. And we've already know that we've got plus root 3, minus root 3, and I seem to have 2 roots here. So I think when you substitute in the 2... Well, no, I'm substituting into equation 1, which is beta plus gamma. Sorry, a little mistake there. We're just working out beta. Beta is negative 5 on 6 minus gamma. So beta is negative 5 on 6 minus 2/3, which is negative 5 on 6 minus 4 on 6, going common denominator. You can just do it on your calculator, which is negative 9 on 6, which is what? Which happens to be the other answer. See, girls, we know that we've only got 4 roots. We have alpha is plus root 3 minus root 3, and I got 2 roots here. So if they have 2 separate answers here, I've got a real problem. But I don't. When I substituted in the 2/3, I got the negative 3 on 2. They're your last 2 roots. One of them's gamma and the other one's beta. Do you understand? No. What it is, I was hoping I would get that when I substitute that I get that. Otherwise, I'm going to end up with 6 roots, and that would be a problem. I'm only supposed to have 4 roots. So I got 2 answers for gamma. So what you would normally do is just finish, because whenever this happens and you get 2 answers, one of them will be gamma and the other one will be beta. All right? But we just did that. We substituted gamma is 2/3 into 1 and we got the beta result. So if I substitute the gamma is negative 3 on 2, I'll get the other one. All right? So that's just the same as what I had up there as the other one. So therefore, the roots are positive root 3, negative root 3, 2/3, and negative 3 on 2. If I substitute negative 3 on 2 in there, I'm going to get 2/3, the other one. See, if I started getting another 2 different answers, you'd get worried. Because you're only meant to have 4 answers altogether, because there's 4 roots. Okay? That's it, girls. Are these the answers? They are. Like, when we look at the problem and we say, solve that, you're expecting answers for x, but we say let the 4 roots, which means the 4 answers for x, be alpha, negative alpha, beta, gamma. Now, a bit of a review for polynomials. If I now look at that original equation, I should be able to substitute any one of my 4 answers and it will work in that equation. So we're going to check them now. All right, just to prove to you. So the actual equation, and the question said to solve this. 6x to the power of 4 plus 5x cubed minus 24x squared minus 15x plus 18 equals 0. And if we solve this equation, then we're saying that these answers, if I put them in one at a time, I should get 0. So I'm going to check if x is root 3. If x is root 3, see, these are my solutions. The roots are my solutions. If you put x is root 3, what do you get? 6 times. What's root 3 to the power of 4? What's root 3 squared is 3. And another root 3 squared is 3, so it's 9. Plus, now, 5 times root 3 cubed. Root 3 times root 3 is 3, and then there's another root 3. Do you get the idea? Yeah. Minus, what's 24 times root 3 squared? Times 3. Minus 15 root 3 plus 18. Equals, no, I'm not going to put what it equals here. I'm going to work it out. So I get 54 plus 15 root 3 minus 72 minus 15 root 3, isn't that nice? Plus 18. And what's 54 and 18? It's 72. 72 minus 72.
0.
Now, if you did negative root 3, that would be the opposite sign this time, it would still work. If you do 2/3, it will work. If you do negative 3 on 2, it will work. Which I could substitute in the 2/3 for the x, or the negative 3 on 2 for the x, and for all those I would get 0 if I did that process for each of those 4 answers. We did polynomials in term 1, and we looked at the factor theorem and the remainder theorem. If something is a factor, see, you know how the roots of my equation were this? That means, do you know that means that polynomial, if I substitute any of those answers in, I get 0? Or it means that, see that polynomial? That if I write it in factored form, if they're the roots, if I write this in factored form, I would get x minus root 3, x plus root 3, x minus 2/3, x plus 3 on 2. This is what it, yes, that these are factors. Sorry. That's the factorized form of that, because I know that my roots are that. You know how your roots are x minus whatever, x minus your root, x minus the root, etc. So girls, once you know what your roots are, or your solutions, like I might say something like this, x squared plus 5x plus 6 equals 0. You know how I know that that's really x plus 3, x plus 2 is 0? So my roots are negative 3 and negative 2. But if I knew that my solutions to that were negative 3 and negative 2 to start off with, I could then write it in factored form. All right? So if I did sum of roots and product of roots, I would get that my x's are negative 3 and negative 2. From that, I could write that. All right? Look, what's sum of roots? Alpha plus beta is minus b on a, it's negative 5. Alpha times beta is c on a is 6. What two numbers multiply to give 6? Negative 3 and negative 2, but add up to give negative 5, negative 3 and negative 2. So if you solved this, let's say you didn't do all this, and you didn't do that, and you just started off with that and said sum of roots is that, product of roots is that, therefore, just by looking at it, I know that one of the roots would be negative 3 and the other root would be negative 2, and it doesn't matter which one's which, all right? So my roots are negative 3 and negative 2. That means the solution to this is x is negative 3 and negative 2, because we always let alpha and beta be the roots. And once you know what your roots are, you can write it in factored form. But remember, factors are x minus your root, x minus the root. So what we've done here is with these answers here, if you know what your roots are, you can write it in factorized form, okay? Now, that's going to lead us to these questions over here. All right, if a is a factor of a polynomial, see how we knew that all these were factors now? When I substituted one of those factors into the polynomial, I got 0. So if something is a factor of a polynomial, then when you put that value into the polynomial for x, you get 0. So I'm going to do this question on this worksheet, exercise 4F. We're going to look at question 9a. So we've got if x minus 3 and x plus 1 are factors of x cubed minus 6x squared plus ax plus b, you have to find a and b, and hence use the sum and the product of the zeros. Now the zeros are the roots to factor the polynomial. Okay? So question 9a, this is from the Cambridge sheet. If x minus 3 and x plus 1 are factors of x cubed minus 6x squared plus ax plus b, find a and b, and hence use sum and product of zeros. Now zeros are really roots. That's just another name for roots to factor the polynomial.
The zeros.
Yeah, the zeros are the roots of the polynomial.
So do we know that alpha and beta are automatically 3 and negative 1?
Yes, that 2 are the roots. Now, how many roots? Yes, we know that 2 are the roots.
So we need 3, so we don't know one.
Well, yes, we don't know what the other one is. So, you know, sum of roots, so 2 of the roots. So the roots are, can you see what some of the roots are? The roots are 3, negative 1, and alpha. So let the roots be 3, -1, and alpha. And because these are factors, there's no remainder. Do you remember when we did division of polynomials? If something's a factor of something, it divides evenly into it. Like it divides into it with no remainder. Okay? So the roots will be, so in other words, this polynomial here is really x minus 3, x plus 1, and x something. We don't know what the other one is. Now you can't work it out because you've got this a, x and b on the end. We can't work it out. Well, it always is minus. It could be minus -5 or minus -2 or something. All right, but it's x minus, I'm going to put alpha in this case. Do you know what I mean? Now, I'm not going to use that, but when you see this, we know 2 of the factors. There's only going to be a third factor because the highest power is 3. Because it's a cubic. Because you always write your roots as x minus the root. X minus the root. Okay, so this x plus 1 originally was x minus -1. So actually I'll write that there. Because see, if x plus 1 is a factor, then where did that come from? X minus -1. So that means that the roots are 3, -1, and alpha. These are my roots. Okay? So the roots are that. What do you think you might... See, sum of roots will be really good. Why? Because look, you've got A, B, C, D. If you do product of roots, you're going to get B and it's going to give you nothing. But, sorry, look what B is. It's a number. And so what? Let's just do sum of roots. So what are your sum of roots? Aren't they 3 plus -1 plus alpha is minus B on A? So I'm adding my 3 roots and it's minus B on A. What's B? So it's minus -6 on 1. So what's 3 plus -1? 2 plus alpha is minus -6 on 1. So 2 plus alpha is 6. So alpha is 4. Girls, sum of roots is minus B on A. Do you know why I chose that? Because in the position of B, I've got a number. In the position of C, I've got A. That's not going to help me. And in the D position, I've got B. How's that going to help me? I'm trying to work out what the last root is. So we've finished. So therefore, alpha is 4. And the other roots are 3 and -1. So I can, if I want... So if I write it in factored form, therefore I've got x minus 3, x plus 1, x minus 4. But we still haven't found A and B, girls, so I still need to do more work here. All right, but that is factored. But they did say use sum and product of zeros to factor, but I didn't. But let's just find A and B now. How are we going to find A and B? Look, you could expand it, but we're going to do it using sum and product of roots. Now, we've done sum of roots 1 at a time. Sum of roots 2 at a time will give me this. What do we do product of roots?
So if you wanted to expand it, you'd expand it and then get the whole...
And then you would end up with that. Yes, that's one way of doing it. But let's just do sum of roots 2 at a time. What do you get? You know what the root... Well, we know what our roots are now. I mean, you get -3. Wait, isn't alpha 4? So what are our roots? So the roots are 3, -1, and 4. So let's do sum of roots 2 at a time. 3 times -1. Yep, plus 3 times 4 is? So I've done those, and these. Minus 4, do you get it? Equals, what's that? C on A. Do you want me to show the working for that?
Yes, please.
All right. So we've got 3 times -1, that's the first one, plus 3 times 4, plus -1 times 4. Do we see? Sum of roots 2 at a time is C on A. So what do we got? -3 plus 12 minus 4 is C on 1, which is C. What's that? 12. Yeah, C is 5. Good. Whoa, whoa, whoa. C, I'm very sorry. What's C in your thing? Girls, just be very careful because C is A and A is 1. Do you get it? Be really careful. Sorry. All right, girls, they really shouldn't have put AX plus B here. It's really bad. But look, sum of roots 2 at a time is C on A. What happens to be C in this position? Look, A, B, it's A on 1, which is A. It's really bad choice of pronumerals. All right, so therefore A is 5. So that's a 5 in there. And product of roots, girls, really bad choice of pronumerals by the book or the authors. Product of roots is, what are my roots?
3
Times -1 times 4 is negative D on A. What's the negative D? So it's negative B on 1. Which is negative B. So
negative
12 is negative B.
So 12
So B is 12. So therefore, your polynomial, and actually we could have worked it out, and I'll show you in a minute how we could have worked it out. Your polynomial, therefore, in factored form is, we know it already, but what is the actual polynomial? x3 minus 6x squared, going back to the question. So the original polynomial really is x cubed. What else?
minus 6x squared
Yep.
plus 5x plus 12.
So x cubed minus 6x squared plus 5x plus 12 is the polynomial. And if you factor it, we know it's this. Now, there was another way to do this.
Can you pull your, if you expand it from the root,
Yeah, I could have done that. I could have expanded that.
and then
There actually is another way of doing this, which I will show you quickly, which is the way I actually did want to do it. I don't know why I didn't do it that way. I'm going to show you another way of doing it. It's just different, which is the way I really did want you to do it. So I'm going to show you another way.
that's method 1.
Yep. Method 2. If x minus 3 and x plus 1 are factors,
Oh, something.
I'm going to show you something. Yeah, you sub it in and you get simultaneous equations. That's the other way. Yeah, I don't know why either. I planned to do it that way. And that was the best way to find A and B, actually, instead of doing what I did. So, girls, there's a few different ways. That way here was best to work out the last root. This other way down here, if these are factors of that, what I could have done is P of 3 is 0. When I substitute the factor, the root, I get 0. So if you put 3 in there for x's, what do you get? See, if these two are factors, then the solutions to the equation are x equals 3. So therefore the roots or solutions are x equals 3 and -1. They're roots.
It'll be 27.
So that means P of 3 is 0 and also P of -1 will also be 0. So if you put 3 in when x is 3, you get 27 minus 6 times 9 is minus 54
3A.
plus 3a plus b is 0. So 3a plus b is 27 minus 54 is negative 27 on the other side. See, this was the other way of working out A and B. It looks a bit quicker to me.
Didn't it tell us to use something?
Yeah, it said no. It said find A and B first and then use sum and product of roots. So I should have done this first, but it doesn't matter. Now, P of -1 is what? This is good because it's revision of what you did earlier. If you put the -1 in there, -1 cubed is -1 minus 6 times 1. What's the next one? Minus, what's next? Minus A plus B. Good. Hello.
You're expecting that?
Yes.
Great.
Yes, yes.
Chat agreement.
Hello, how are you? Okay. Okay, what do we do next? Don't be. Yeah, I'll just stop recording for a second. Yeah, and what would be on the next row? let's just take that number over. Negative A plus B is? Good. What do I then write?
Equation 2.
Good. Now what have we got? Yep, solve simultaneously.
B's are the same.
Yes, the B's are the same. We can do that. Yep.
1 minus 2.
Yeah, you could do that. Or why don't we just subtract? Equation 1 minus 2. Is that what you all said?
Yeah.
Okay, what do we get? Have a go.
4A.
Yep.
4A equals 20.
Good. So,
A equals 5.
and then? Yep. Anything that's easy.
2.
And what do we get?
Negative 5 plus B equals 7.
And I'm still on the page.
Equals 12.
So that was the other way of doing it.
Thank you.
Okay, no worries. Okay, so A is 5, B is 12. Right. Yeah, you can watch it, but I wanted to do a whole lot of stuff off this sheet.
What's the difference between watching the video and seeing it?
Well, you can. All right, next question, we'll start. Question 10 off the Cambridge sheet. Shh. Find the values of A and B, question 10, for which x cubed plus ax squared, girls, minus 10x plus b, this one's a bit different, is exactly, one sec, divisible by x squared plus x minus 12. Next question, question 10a. Find the values of a and b for which x cubed plus ax squared minus 10x plus b is exactly divisible by x squared plus x minus 12. Well, girls, I don't know what the factors are, so what can you do? If it's exactly divisible by that, I should factorize that and then do the p whatever is 0, similar to what I did before. Well, so what you do, you would get x minus 3, just double check it as well when you've done it. So, do you know what the factors are then? What two of the factors are? It's a cubic. And we've already just worked out what two of the factors are. So, two of the roots or two of the factors, or two of the roots, two of the solutions are x equals what? No. Because the roots are written x minus alpha, like x minus your root, x minus the root. So the... Yes, I just factorised. So two of the roots of your quadratic are 3, because it's got to be in the format x minus the root, x minus the root. So the x plus 4 is x minus negative 4. No. Now we've just got to do the same as what you just did in question 9. You know what two of the roots are. Therefore, p of 3 will be 0 and p of negative 4 will be 0. And then you can do that and it'll give you two simultaneous equations which you can solve to find A and B. Do you get that? See, if it's exactly divisible by that, it means that when you divide that in there, you'll get an answer, but no remainders. So therefore, you factorise this. They're the roots. Anyway, what do we get for P of 3? 27.
27 plus 9a.
Plus 9a minus plus b is 0. So 9a plus b is, well, we've got negative 3 there, so it's positive 3. Get the idea? Girls, this is really good revision of the polynomials we did earlier this year, all right? And if you put in negative 4, you get negative 64 plus 16x squared, sorry, 16a, 16a, what do we get? Plus 40 plus b is 0. So you've got 16a plus b is, I think we've got negative 24 on that side, positive 24 on this side. Solving simultaneously. Why don't we do 2 minus 1 so we get no negatives? The b's are the same again. 2 minus 1 gives me, all good? 7a is 21, so a is?
3.
All good. and sub into equation 2 will do. 16 times 3 plus b is 24. B is 24 minus, what are 16 threes?
16 what?
I worked it out a minute ago. What are 16 threes? So b is, so therefore your equation is x cubed plus, see, your polynomial, what is it? X cubed plus x squared minus 10x minus 24. And then girls, if you had to, you know, just by inspection, just one sec before you go, girls, it's really actually easy. I'm going to factorize it. You know, by comparing that with this, if you multiply the constant terms, you get that last one. Negative 3 times 4 is negative 12. Tell me what the, plus or minus 2? Plus. Girls, if I expand this, yes, I'll get all these big combinations. What you do, check that it's monic, and if it's monic, you just multiply the 3 constants. That's the only way you'll get that last term. So negative 3 times 4 is negative 12. Sorry, and times it by positive 2, you get negative 24. Do you see that? So we've got negative 3 times 4 times something is negative 24. I'll call it alpha. So the last root is positive 2. So that's the factorized form. Okay, girls? Now,